In Chapter 9, we will take the concept of sampling distributions and confidence intervals to the next step. We will learn how to formulate and prove hypotheses about the population parameters using sample statistics. In this first lecture, we will look at how we develop the null and alternative hypotheses. Testing requires that we develop a null hypothesis, which is our tentative assumption about the population. Then we will develop the alternative hypothesis, which is the opposite of the null hypothesis. The test we will use is to take sample data to try and reject the null hypothesis. The first and sometimes the biggest challenge is to determine how to formulate those hypotheses from the given situation or problem statement. We have to be careful because our making a correct conclusion requires that we set up the hypotheses the right way. In some cases, the null hypothesis easily comes to mind. In other cases, we must formulate the alternative hypothesis first. When the situation involves trying to prove something or prove a research hypothesis, it's best to formulate the alternative hypothesis as the conclusion that the researcher is supporting. What are you trying to prove? The null hypothesis will then be the opposite of that. For example, we are trying to prove that a new method is better. Therefore, the alternative hypothesis would be the new teaching method is better. And the null hypothesis would be that the new teaching method is no better than the old method. Similarly, with the example of developing a new sales plan, we are trying to prove that a new sales plan is better. The alternative hypothesis is the new bonus plan will increase sales. The null hypothesis is the new plan does not increase sales. And again, using an example for a new drug, we see the alternative and therefore the null hypothesis. In other cases, we can begin with the belief that some statement about the population parameter is true. The hypothesis test would be used to challenge that assumption. This then leads to developing the null hypothesis first. A production process is a good example of this approach. We believe that the process is in control and that the bottle contains at least that minimum amount. Therefore, the null hypothesis is the population mean is greater than or equal to that minimum amount. And the alternative hypothesis would be the opposite. The population mean is less than that amount. This slide shows a summary of the three types of null and alternative hypothesis forms: one-tailed lower, one-tailed upper, and a two-tailed test. Now, if you look closely at this, the null hypothesis H0 in all three cases has the equal sign as part of the relationship, and the alternative hypothesis in all three cases does not have the equal sign. It's either greater than, less than, or not equal to. Sometimes the statement of the problem will give us a hint as to what our null or alternative hypothesis should be, looking for an indication of greater than or equal to, less than or equal to, or equal to would tell us it's the null hypothesis. Let's consider an example of developing hypotheses. The wording sounds like we are trying to prove that the hospital is meeting their goal of 12 minutes or less. And we want to formulate a hypothesis test that will use a sample. Note that we are making a statement. The service goal is less than or equal to 12 minutes. That sounds like the hypothesis. Therefore, the null hypothesis, the emergency service is meeting the goal. The alternative is it's not meeting the goal and we need to do something about it. In this case, mu is the mean response time for the population of the medical emergency requests. And 12 is our hypothesized mean.